Hi.
Hi, are you sure you can prepare for product based companies through this course?
Yes, sitting at home?
No way!
Yes, way. Don't delay. Yes.
Hey, what do you mean by a self paced course?
Well, the course material is available in the form of video lectures. And there are multiple practice problems that come along as well. So, you can access all of it anywhere, anytime. And they are available to you for lifetime.
No way!
Oh, yes, way. Don't delay and enroll now.
Geeks learning together.
Yeah, hello, good evening, everyone. Can I please have a +1 in the chat box, those who are with me right now, and just give me a confirmation that I am properly audible and visible. Yeah, hello. Yeah, I could see quite a lot of people live with me right now. It will be really great if you could just do a +1 in the chat box and just mention visible. Okay, and there is no network connectivity issue or anything else. Delay that there were due to some issue, I could not start the stream on time. Properly visible. Hello, Yashwant. How are you? Can you please borrow the problem? Yeah, so what do you think should be okay? Yashwant, is my voice very clear right now? And today also we will be continuing with dynamic programming. Yeah, hello Tejas, how are you? Okay, so let me give you a small introduction about the series that we are presently having. This is called the practice session for SDE interviews, and in this session series, we are presently taking up a few topics and then discussing questions related to those particular topics. Okay, so yeah, so this week presently we are doing dynamic programming, and in the next week we will be starting with graphs. So apart from that, there is something called as complete interview preparation, which is an extremely beneficial course if you are preparing for your interviews. Okay, so you can check out this course on the GFG platform. Okay, so basically this particular course has been well crafted. Yeah, hello Lokesh, how are you? So, can you please tell you are in which year of your college right now, and are you preparing for your interviews? Okay, so today we will be again focusing majorly upon dynamic programming. Okay, yeah. So I remember. So last week I was doing a problem on DP on stocks. If you remember it very carefully, in that problem we were asked that you were given us the price of stocks for n days, and you were wanted to and you were asked to find the maximum profit. Okay. So let's continue with a similar question, but of a little bit difficulty level. Okay. So so let's do the problem on buying and selling a stock. Four. Okay. So, if anyone would like to give a recap of the last problem, what are the conditions? And this problem is also very similar to the last problem, except there will be a few changes in the conditions of the problem statement. Okay. So let me note down the conditions for the problem statement, and then we can proceed. So basically, you are given an array of length n. It represents the price of stock for n days, and the following guidelines are basically given to you once again. Okay, so let me just put it here. Give me a minute. Let me put a text box here. Okay, yeah. So okay, yeah. So you can see all the instructions mentioned on this particular text. Okay, so you are given an array. The length of the array is n. It represents the price of stock on n days. The following guidelines need to be followed. You can buy and sell the stock any number of times, and in order to sell the stock, you need to first buy on it on the same or previous day. Second, it is given you can't buy a stock again after buying it once. In other words, we first buy a stock and then sell it. So for a transaction to happen, you must first buy a stock and then sell the stock. Okay. After selling, we can buy and sell again, but we can't sell before buying and can't buy before selling any previously bought stock. So you have to make sure that all these rules of transactions are being followed, and you can do at most k transaction. So in the last week when we did the same problem in which the value of k was equal to 2, it means that you are only allowed to do 2 transactions, and in that way you have to find the maximum profit. Okay, so this was the question. But here you can do at most k transaction. It means that you can either do 0 transaction, 1 transaction, 2, 3, 4, but up to k. So you can only do k transaction. So can anyone tell me the DP states that we will follow? Because this problem is very similar to the last week's problem. You can just iterate upon the DP state that we have discussed previously. Okay, can anyone tell me what are the modifications that we can do to the DP state that will help us to solve this question? Okay. Hello Lokesh, hello Tejas, hello Yashwant. I hope I am properly audible and visible right now without any disturbance. Okay. Okay. So I would request all of you all to kindly do a +1 in the chat box if you are joining the session for the first time. Hello Yashwant. Yeah. So tell me, Yashwant. Yes, yes, I know that I am properly audible and visible. I wanted to know, tell me that what do you think will be the DP states for this particular question? And if you remember the last question, the last week's question, what are the modifications that we can do to the previous DP states that will help us solve this question? Okay, so let me tell you the exact approach that we will be trying to use here. So, as usual, let us first write a brute force recursive solution that we can implement. Okay, so for that, what we can do here is that we can write a function called intf. This will basically accept a vector of arrays, okay, which is basically the stock price. It will also accept a vector integer n, the size of the vector, another integer index, the present index that we are presently on. It will also have a variable called by. It will also have a variable called cap. Okay, so these are the two variables that we will have. As if you remember very carefully, this was keeping track of whether we are buying it or not. Okay, so this is keeping track of buy or not. Okay, and this is basically keeping track of the number of transactions. Okay. Hmm. So there were a few recursive conditions that we must follow. So let me just tell you that. For example, if you're standing on any particular stock on any particular day, so there are two options. You can either do a buy a stock or you cannot, or you do nothing. Okay. And if you buy a stock, then you have two options. You can either sell a stock or do nothing. Okay. And if you're doing nothing, once again you can either buy a stock or do nothing. So the point is that once you buy a stock, you can only sell the stock. It's not like that if you buy a stock, you are not allowed to buy it again. So this is the basic recursion, different types of recursion trees that will get formed, or the possible choices that you have for every stock. Okay, so that is the reason we have to make sure we know that what was the state of this variable buy in the previous recursion. Okay, because if let's say you bought a stock, it means that now it's time to sell a stock or do nothing. Okay, so that is the reason we need to keep a variable called buy. Okay, I hope this part is clear. So if this is clear, can I please have a plus one in the chat box? Lokesh, Yeshwant, Tejas, can I please have a plus one in the chat box? Yeah, I see quite a lot of people live with me right now. Can you all please do a plus one in the chat box so that I could get to know your names, and also it will also give an indication that you guys are properly understanding. Okay. So before I proceed further, let me just give you a small introduction about the course that we are having. So the name of the course is Complete Interview Preparation, and if you're preparing for your interviews, that particular course is an extremely well-structured course which contains all the necessary important topics for your interview preparation. Okay. Okay. So okay, thank you, Yashwant. Thank you, Lokesh. So let me write the recursive solutions that we can presently have. So, so the first thing that we can do here is that we have to first check that whether we have already bought a stock or not. For example, if we buy a stock, we can write if buy is equal to zero. Okay. So what we can basically do is that so if the buy is equal to zero, it means that it's time to buy a stock or do nothing. So there will be two cases. So we are and we always have to take the maximum of both the cases. So the first case will be that you are doing nothing. If you're doing nothing, you add zero to your answer, and because you're not having any profit, because if you are making any transaction, in that case only you will have a profit. But if you're not making any transaction, in that case you won't be having any profit. So that is the reason you will be adding zero to your answer. Okay, so this is the do nothing case. Then what you will do, you will call this function and call f of arr comma n comma index plus one. You are moving to the next index, and after that what you are doing. So the variable buy. So buy will still remain zero because you haven't done anything, because you haven't bought the stock. So this will be one condition. The next condition will be that you buy a particular stock. So if you're buying a particular stock, it means that you're giving away your money. So in that case, what you will do, you will just add a negative value, negative of ARR of end, because this is the money that you are giving to buy a stock. So that is the reason you will subtract this money from your profit. Okay, why we are subtracting? Because once we are basically selling that particular stock, we are again recovering back our money. Okay, it may be a profit, but it may be a loss, but you are recovering. So once you're selling, you will always use a positive convention, and once you're buying, you will always make a negative convention. Okay, so this is just a convention that will help you solve the question. Okay, so once again, all these things will remain same. You're moving to index plus one, but this time instead of zero, you will be writing one. Okay. So yeah, apart from that, we also have a variable called cap. So this cap will remain same because you have just bought. In this case, you did nothing, and in this case, you bought a stock. So this doesn't complete the transaction. We will only increment cap if we are completing a transaction. Okay. Now the next condition will be that if buy is equal to one, if buy is equal to one. Okay. So in that case, what will happen? We will again have two choices. We can either sell our stock and complete a transaction, or do nothing and wait for the and we go to the next day, so as to make sure that we are having we may get a better stock to sell. Okay, so what we will do basically is that we will again have we will again have two choices. The first choice will be something like this. We can write 0 plus f of so So ARR and then again n, because we did nothing. In that case, we'll just write n plus 1. And in this case, we'll just pass on with our value 1, and cap will remain same. But in case if we decide to sell that particular stock, we will add positive value to our profit, which is equal to the value of the stock on that particular day. Now we will again recursively call the same function with the values ARR n. We will again move an index with 1. Since we have already sold the stock, the value of buy will become 0, and the value of cap will also decrease by 1 because we have completed a transaction. So always remember, a transaction gets completed only when you are selling a stock and not when you are buying a stock. Okay. So we are writing a comment here. A transaction will only get completed. A transaction will get completed only if we are selling a stock. Okay. So then only what you will do, you will decrease the value of cap by 1. Okay. So these are the two conditions that you have to make sure. Now what you will do, you will return profit. Okay. So yeah, but this will basically give you a time limit exceeded because it is an exponential complexity. So what we have to do basically, we have to declare a DP state as well. Okay. So before we move on to the DP state, we have to first write the base cases of our recursion. Okay. So the base cases of a recursion will be, um, so the first case will be if index is equal to n. It means that you have exhausted your all the days that you are allowed to do your trading. So what you will do basically is that in that case you will return 0, or if your number of transactions that you are supposed to do has become equal to 0, because you can only do maximum of k number of transactions. So in that case you will return 0. Okay. So this is very similar to the problem that we did in the last time, but instead in which the cap was 2, but this time cap will be k. And the DP states will also change, and the value of and the time complexity and the space complexity will also change depending upon the constraints of k. Okay. So now it's time to declare a DP state. Okay. So can anyone tell me what do you think will be the DP state here? Because we want to optimize this approach. Hello Yashwant. Hello Lokesh. Hello Tejas. Okay. So can you yeah. So can I please have a plus one in the chat box if you have properly understood till here, so that I can continue writing the DP states. So let me write the DP state now. So first of all, what are the states that we will have? We will have a state called index because the index, the number of days we are trying to move. Then we will also have a state called buy because it can either have a value of 0 or 1. And we'll also have a state called tap. So this is the DP state that we will declare. And before we move here, we will just check that whether the DP of these particular values is not equal to -1 or not. If it is not equal to -1 or not, we will just return that particular DP. Okay. And if it is equal to -1, in that case, we will do our recursion. Okay, so we will continue with our recursive calls for the function. And after that, what we will do? So once we get this value profit, we will just put it in that particular DP table. Okay, so instead of just returning profit, I will put it here, dp of whatever values we are presently in, and we'll put a profit here. Okay, so this will basically make sure that I have completed. Okay, so now it's time to discuss the time and space complexity of this question. Can anyone tell me the time complexity and the space complexity? Hmm. What do you think will be the time complexity and the space complexity? Lokesh, Yashwant, can you please tell me what do you think will be the time and space complexity of the question? Hello Yashwant, are you there? Hello Lokesh, are you there? Yeah. Hello Lokesh. Yeah. So let me discuss the time and space complexity, and then we can wrap up our discussion for today. So the time complexity will be n. Okay. So n is the number of days, and in this case we will be multiplying with the two because the states of y, and we'll also be multiplying with k. Okay, because k is the number of transactions that you can take. Space complexity will also be n into 2 into k plus a recursion stack space. Okay, and that will be O of n. Okay, so this is the recursion stack space. And if we are writing this code from a tabulation point of view, in that case, we won't be requiring this recursion stack space. Okay, so this part of is called the recursion stack space. I hope everyone understood this question. So before we wrap up our today's session, let me give you a small introduction about this particular course called Complete Interview Preparation. So if you are preparing for your interviews, you can definitely check out that particular course. It's an extremely well-crafted course that will help you prepare for your interviews. Okay, and apart from that, yeah, and apart from that, I would request all of you all to kindly attend this particular session that we are presently having, and because if you're preparing for your interviews, this will basically help you. Okay, and this particular session is live streaming on YouTube on every Monday, Tuesday, and Wednesday at 9 p.m. Okay, so let us wrap our session for today, and then we can continue it tomorrow. Have a good day.